So this is a brief mathematical digression on the cross product of two vectors. Hopefully you've seen this somewhere before, but if you haven't, you can learn it here, at least in a not extremely mathematical way, or at least in a way that might make mathematicians unhappy. So if you remember, we had the dot product of two vectors. If I have a vector A dot product with a vector B, and my vector A is a sub x I hat plus a sub y j hat plus a sub z k hat, and my vector B is equal to bx I hat plus by j hat plus bz k hat. This is the dot product, as opposed, or the scalar product. What we get is ax bx plus ay by plus az bz, and we showed that that was equal to the magnitude of A times the magnitude of the vector B times the cosine of the angle between them. And so, you know, if this is my vector A and this is my vector B, then and this is the angle theta, this dot product is equal to this, and we showed that in a previous mathematical digression. The cross product, so the scalar product of two vectors is a scalar. That is to say, the dot product is just a number, right? The cross product of these two vectors is a vector, and I'll tell you what it is first in terms of just this sort of an argument. If this is my vector A and this is my vector B, and the angle between them is theta, then A cross B is equal to, or the magnitude of that is equal to the magnitude of the vector A times the magnitude of the vector B times the sine of the angle between them. Assuming it's a positive angle, otherwise I have to take the magnitude of it. And so that's the magnitude of the cross product. The direction is from the right-hand rule. So the right-hand rule is I lay my hand along vector A, or actually my forearm, but my table's twisted too much for me to do that. And then I curl my fingers towards B, and so if A is going this way and B is going this way, I curl my fingers this way and stick my thumb out. My vector points up, and so this would be, if these were my two vectors, and this is then the direction would be out of the plane. I'll show you the formula for it, the way you calculate it in general, and then I'll just sort of show this for a very simple case. And you can consult your math text if you want a more rigorous example. So I'll go back to my two vectors. Here's my vector A, which is ax I hat plus ay j hat plus az k hat, and my vector B is bx I hat plus by j hat plus bz k hat. And in order to take the cross product, A cross B, it's done this way. It's done by taking the determinant of this 3 by 3 matrix. Hopefully you guys know how to do determinants. I'm hoping so. So it's the determinant of that 3 by 3 matrix. And the way to take a determinant is you take the first guy and you multiply him by that times that minus that times that. So ay bz minus by ac. So it's that guy times that minus that times that. And then it's minus j hat times the same thing for it instead. So we pick this guy, it's that times that minus that times that. So it's ax b z minus bx az. That times that times that minus that times that, except with a minus sign, and then back to the plus sign, k hat times ax by minus bx ay. And that's a cross product. Notice it's a vector. It's I hat minus j hat plus k hat, each time some combination of the coefficients in these guys. And so I can say, so as a simple example, I'll say consider A equals ax I hat plus ay j hat, and B is equal to bx I hat plus by j hat, both in the yz plane, so they have no z component. I'm just going to do a simple case here. And so if this is my coordinate system, right, if this is my y and this is my x, then I can have a vector A that's going off this way and a vector B that's going off that way. Sorry. And then I can say, look, this is my AY, this is my AX. I didn't do that very well, but you get the idea. This is my BX, and this is my BY. I can call this angle, say, theta, and this angle, say, phi. And then if I do my cross product, you'll notice since each of these guys, AZ is 0 and BZ is 0, that that if I write out the cross product, if I were to do all this work for these two vectors, I would get A cross B is equal to, so this has a BZ and an AZ, and so both of these guys would be 0 because I don't have any Z's. This guy be 0 and this guy be 0 because that's a BZ and an AZ. So the only guy left would be k hat times ax by minus bx ay. And that's k hat times, and so ax is just a cosine theta, and by is b sine phi minus b cosine phi a sine theta. That's what this would simplify to, or expand to, maybe, if you want to call it that. And so this would be AB, where again, A equals the magnitude of the vector A, and B equals the magnitude of the vector B. Right? And so this is AB k hat times cosine theta sine phi minus cosine phi sine theta. Well, that's just a difference formula for the angle. That's just k hat times AB sine of phi minus theta. That's just the magnitude of A times the magnitude of B times the sine of the angle between them. This is the angle between the vectors A and B. I haven't shown it for the general case, but I can show it for a simple case, that this cross product, this thing we're calculating here, in fact gives the magnitude of the that we were talking about earlier, magnitude of A times magnitude of B times the sine of the angle between them. So I can say another word or two about that. Once you sort of accept that form of the argument, again, your math teacher would give you a better explanation for it than I just did. But we can say if this is my vector A and this is my vector B, then if this is the angle between them, so I said this one had a theta angle and this one had a phi angle, but now if I just say theta is just the angle between the two, since that's all I'm really interested in is the angle between the two, then I can say, look, I can say this piece right here is b sine theta, right? And so AB sine theta is the area of this parallelogram, right? It's A times B sine theta, which is the height. The area of a parallelogram is the length of the base times the height of the parallelogram. If you wanted to, you could take this little triangle off here. It's similar to this triangle. Stick it over here like this. And then you'd have a little rectangle whose base was A and whose height was B sine theta. And so the magnitude of A cross B is the area of the parallelogram made by the vectors A and B. So it's determined by the right-hand rule. Put your fingers along A, curl your fingers towards B, stick your thumb out for the direction of C. And so I'll give you just a couple of examples of that here real quick. Let's do some that I can draw. Right? And so if this is A, right, that's my vector A, and I want a cross product with B, just like this, I would stick my hand in the A. Hang on. Cross product of two vectors. So if I want to do an example, and this is vector A and I want to cross it with B, I start out by sticking my my forearm slash hand in the direction along A. And now I want to curl towards B. I'm not allowed to curl this way because B goes the other way, and so I have to turn my hand over so I can curl towards B. I have to curl the shortest way towards B. And that means my thumb is into the board, right? And so I would say, I would give the direction of C equals A cross B as into the board. Those are supposed to be tail feathers. That's into the board. And so now I can, so there's one. Let's do another one. Let's say, let's say here is A, and now B is coming out of the board, right? And so once again, I put my hand in the direction of A, and now I need to curl my fingers out of the board. So to do that, I have to rotate my hand this way so that I can curl my fingers up towards B, because B points out of the board. And that means my C points that way. A cross B gives me C. All right, those are a few examples.